before we do that, let's start with a couple of ideas. Okay, so if you look at the screen, okay, you picked up 2 papers when you came in today, okay? 2 papers. You had an assignment that was due today that was from section 6.1, okay? I want you to, first of all, the papers you picked up, there were 2 of them. One of them is notes, the other one will be an assignment, okay? So I need you to listen, so you know what I want you to do. First thing, we're going to not take up the homework until we've had a chance to talk about a couple of problems from it. So you should have gone home and completed page 296, 1 through 21 odd, and 27 and 28. I anticipated that maybe we should discuss 19 and give you a moment to do 21 if you struggled with 19. So we're going to do that in a few minutes, okay? At this time, I want you to look at your worksheet that you picked up today. There's some new ideas there, okay? You should see this page, okay? I'll get it in a second. Okay, so you should see this page. And while I'm taking attendance, I'd like you to do problems 1, 3, and 13 from this worksheet. 1, 3, and 13. Start with that. So you're beginning with the worksheet 1, 3, and 13. Claire, 2 papers.
Yes, I got it. I got 19 in the first set.
So start there, and I'll explain everything else. Just start there. Let me get it in there. Starting there. August, what is the angle bisector in the picture?
GC.
GC, very good. And you know it because of the marks, right? So this is segment GC. Everybody got that one?
But it says
Angle bisector.
G, look at G.
At G, you are decided, you're cutting them in half, right? That has to be marked for it to be an angle bisector, okay? All right, we're gonna get to the others in a moment. Look at number 3, okay? This is what we did yesterday. Chelsea, what is the perpendicular bisector in that triangle? BA or AB. And to be a perpendicular bisector, you have to be cutting the segment in half so that these pieces are congruent and intersecting it at a right angle. Okay, yes ma'am?
Could I also put FD because it also says that?
Okay, FD is a perpendicular, but it is not bisecting the segment. Okay? And if it was, you would have to know DE and DG would be congruent. Does that make sense? Okay, anybody else? Questions? Okay, so those are the things we looked at yesterday. Okay, we're gonna add a couple things to what we know today. Before we go back and look at the notes, I want to go on, I told you to draw number 13. Let's see how you did on that. Number 13, you could have a drawing that looks like any of these, okay? What has to happen here is S has to be on the same line in between G and I. So it should be something in a row, right? On the same line, to be between. Between means collinear, okay? This goes way back, okay? And then you gotta have triangle GHI. So I don't know if you do it like this or like this, but these are all examples of what would work. So kind of compare your drawing. How do we do? And also look at your drawing, and did you mark the angles? Did you mark the angles? These do not have to be congruent, right?
Right.
Between just means they're on the same line, okay? So the only thing marked is the angles, and your letters need to be in the right spot. Is that okay? So you're gonna be doing a little bit of drawing in this assignment that you'll be doing today. And we got a few new vocabulary terms. Before we, go over the homework, I wanna point out to you on this worksheet, we're gonna omit problem 17. If you would go to problem 17 on that worksheet and mark it out, omitting problem 17. All right, everybody make a note of that. Catherine, you paying attention?
Yes.
We're omitting 17 on this worksheet, okay? So you will have one proof to do based on this assignment, okay? Now at this time, let's go back and talk about your homework, okay? So in your homework, you were using the textbook, okay? So if you look at the textbook, these are the pictures you did, okay? And in the beginning, you were trying to come up with those parts, and you went through and you checked yourself, and you should have explained giving the theorem as you went through it, okay? So I'm gonna go 1 through 15. Are there any questions on the 1 through 15 odd part? Anybody? I anticipate we need to look at 19. Anything before that?
19.
Just 19 and 21?
Answer to 28. Yeah.
And 28, those are the ones I want to discuss, okay? So let's go to 19. 19 tells us, write the equation of the perpendicular bisector of the segment with the given endpoints. Okay, so when you were doing this, you should have begun by doing a drawing, yes? And plotting the points, okay? So you plotted something that looks kind of like this, okay? This is number 19. Okay, so once you draw this and you put the points in, if I'm gonna do a perpendicular bisector to this, I need to find what?
The middle?
The middle, okay? So the first thing that you do is do the midpoint, and I'll do this on my screen, so it'll go in the video, okay? So, to do number 19, we'll start with the midpoint, okay? Which means we're gonna go x1 plus x2 over 2, comma, y1 plus y2 over 2, right? To get that midpoint, okay? So on the board here, we have -1, 5, okay? So my x's are -1 and 3, 6, is it 7, -1?
Yep.
7, -1. So you're gonna go -1 plus 7 over 2, okay? And then the other point was the y values are 5 and -1. So 5 plus -1 over 2. This will help us get the midpoint, right? Everybody comfortable? Okay, so we get the midpoint. This is gonna be 6 over 2,
30.
or 3, and 4 over 2, 2, the 0.32. Okay, so on the drawing, it would be 1, 2, 3. That's not a very good drawing, is it? Okay, should be 3, 2, 1, 2, 3. That's really not drawn well. Okay, 3, 2. Y'all agree on the midpoint? I'll make sure I looked at it correctly. Once you get the midpoint, then you have to do what? You have to find the slope. And remember, okay, so here's not the points, but if your points are here, and we just figured out the midpoint, okay? And we want the equation of the perpendicular bisector, we're gonna have to be at a right angle to that point, right? So when we find this slope, we need the opposite reciprocal slope to have this slope, right? Okay, so we're gonna find the slope now, and we figured out this was 3.2. Okay, so now that we know that, we'll take our 2 points and we'll do the slope formula. Now, you can do them on the graph by rise and run and count. Hollister, you have a question?
Is the midpoint 3.2 or 4.2?
Isn't it 4/2, which is 2? Okay, let me look in the book.
On the graph, it's.
Let me make sure. Okay, the points were 1, 5,
Yeah, that's
and 7, -1. Okay, so this is wrong, because that was not -1. It was positive. Okay, so let me fix it. What would that be? It's gonna be 4.2, right?
Yes.
I thought it was late.
Okay, thank you. Okay, so 4.2 is our point, correct?
Yes.
Okay, so thank you. All right, now that we know that, we're gonna get the slope using these 2 points. So I was trying to, okay, so the slope's gonna be, how, the formula? What's the formula? Rise over run, y2 minus y1 over x2 minus x1. So you can count it on your graph, if you've got a nice graph, or you can go -1 minus 5 over 7 minus 1. This will give us the slope. Now that's the slope of that red segment, right? Okay, so this is -6 over 6, or -1. So -1, gosh, I can't squeeze this on there. Okay, so if I get -1, that's the slope of the red segment. All right, I want the slope of the perpendicular. What is it? It's just 1. Because remember, you want the opposite reciprocal, right? So the opposite sign, flip over the 1/1, you get 1. So +1 would be the slope of the perpendicular, right? Okay, so you're gonna go, the slope of the perpendicular line equals +1, which is the opposite reciprocal of what I had, right? And then you're gonna take the point that you figured out for your midpoint, and what now? How do you write a line?
I thought that, wait, the midpoint is 4.2?
Yes, it was 4.2. We had a negative in there we didn't need a while ago. Okay? So what do you do here? How do you get the line?
Start the point slope form.
Point slope form, right? Do y'all remember? It's been probably 2 or 3 months. Okay? So we're gonna go y minus y1 equals m times x minus x1. Y'all should have that memorized, right? And you're gonna plug in the x4 and the y2 where the subscripts are, 2. You're gonna put the slope we're using here. And then we're gonna simplify, right? Is that making sense? All right, so this would be x minus 4, add the 2, and y is equal to x minus 2, and that would be your answer, okay? Okay, so what did we do? We found the slope of the segment. No, the first thing we did was find the midpoint of the segment, right? Then we noted that point, then we found the slope of the segment, and we got the opposite reciprocal of it. And then we had the slope we need for the perpendicular, and we went point slope form and simplified it. Okay, solve for y. Okay, so that's how number 19 and 21 work, okay? So let's go back and look at those 2 college problems. I think you had 2 good college problems there. There we go. Okay, so you had to do this problem, okay? What is the value of x in the figure? Okay, so 3x minus 9 equals what? 45 degrees. Now, before we just say it's 45, why is it 45?
Because of the 90 degrees angle bisector.
Is it just because that's a right angle, is it 45?
Because the two.
90
points-
degrees and it's a bisector. so
It's
it
the
doesn't have to
converse.
be-
Okay, how do you know it's a bisector?
Because the distance from the point to the other two sides is equal, so using the converse, that means that the angles are equal as well.
Ooh, very good, okay? Now, did you think about all that when you thought about that angle being 45? That's actually the reason that you're using. This is equidistant from the sides of the angle, which implies that this is an angle bisector, which is the converse of the angle bisector theorem, right?
Yeah.
Okay, all right, so there's that one. The answer to that was B. Okay, then you also did this problem, somewhere. Is it that one? Yeah.
Yes.
Which point lies on the perpendicular bisector of the segment with these endpoints? Okay, the answer is B. Okay? Now, how do you do this? Who knows? All right, what do you do, Hudson?
So you take the two points, bottom, and find their midpoint.
Okay? All right, so if I did that, I would get 6/2, 0, right? No, 6/2, 5.
Yeah.
I get 6/2, 5 if I went x1 plus x2/2, 5 plus 5/2. So I would get 3, 5. Now, if that's my answer, I'm good, but it's not, so what else?
So, because it's the midpoint and it's equidistant to the two other points, the point that'll be perpendicular will be on the same x as it,
The same x as it, why?
because of what theorem is that?
Okay, without the theorem, tell me why. Why you're going to me like this, why like this?
Because it's equidistant.
Why like this?
So the slope of the original line is just like flat, so it's unplanned.
You knew that, didn't you?
Yes.
Okay, so the
Why?
slope is 0.
Why?
So the perpendicular one is straight up and down, which then means it has.
Okay, so you actually knew this, you didn't know what to tell me. But you know that because these are the same, right?
Yes.
Okay, so something 5 is, you got this, she's saying, okay? And so he's telling me it's gotta be that. And so it has to be
On the 3.
x equal 3 something, right? Does that make sense? So nice little college prep problem. Good SAT question, okay? That's the kind of stuff they ask us. Any questions? Okay, so on the homework, if you struggled with 19, try 21 before you turn it in. You're gonna have a few minutes in just a little bit, okay? So before you turn in that homework, make sure you know how to do that problem, okay? So with that said, let's take a quick look at what I've got you doing today, okay? I have some notes for you, and most of the notes are just kind of going through some things, okay? So, just to walk you through what I gave you, there are 2 new vocabulary words. They are median, and you see a picture drawn, and a definition. Okay, so a median is a segment in a triangle that connects a vertex to the midpoints of the opposite side, okay? So in this picture, I drew you an example, and if it's going from a vertex to the midpoint of the opposite side, you would mark these equal if you were drawing it, okay? Now, how many medians would there be in a triangle? How many medians would there be in a triangle? How many? How many? 3, right? You got 3 vertices. You got 3 midpoints of the opposite side, right? So it didn't tell me to do this, but just to make sure you understand, here's a vertex. If I draw another median, I'm gonna go to the midpoint of the opposite side, which means these are gonna be equal, right? And it would look like that, right? And the other one would be, here's the midpoint of the opposite side. I gotta come from the vertex to the midpoint, which means these are gonna be equal, okay? And then drawing it, you should notice they all land in one point. That point has a special name. We'll talk about those later. Everybody with me so far? Okay, so that's the medians, from a vertex to the midpoint of the opposite side. Now let's talk about altitudes. Okay, an altitude is a segment in a triangle that connects a vertex to the side opposite, forming a perpendicular. Now, to think about that definition is a little harder than just to think about what an altitude represents most of the time. Your altitude is how high you are. If you're in a plane and your altitude is 50,000 feet, that's straight up from the ground, right? So this is a height. Every time you draw it, it's a height. But it comes from a vertex to the opposite side, which means it forms a perpendicular because it's straight up, okay? So an altitude, every triangle would have 3 altitudes, depending on which side the triangle is sitting on, right? Okay, so if it's sitting here, the height is not this one, right? It's not this one. The height here, then it would, to be flat on the ground, it would be tilted a little bit, right? So visualize it being tilted a little bit. Straight up, what would be the height? Can you draw it? From a vertex perpendicular to this side, right? So from this vertex perpendicular to this side, if this was down a little bit, right? Okay, so attempt to draw that. From a vertex, yes sir?
What's the difference between altitude and median? They're just,
An altitude is from a vertex perpendicular to the opposite side. A median is from a vertex to the midpoint of the opposite side. Right? That's why we marked all those congruent, because it goes to the midpoint. That make sense? Okay, now the altitude represents the height, okay? So in this triangle, if I could take the screen and turn it around and sit it like that, this would be how tall that triangle would be, right?
Yeah.
Okay, so that would be like the height with this base, yes? This base would have a different height. It would not necessarily go to the middle. It would probably be more like right here, right?
Yeah.
Okay, so I'm asking you to sketch please, okay? So it says use a straight edge. You're just really doing a really good sketch. If you need to use a ruler, you can. Okay, does that look like a right angle? We're kind of doing a sketch, okay? So if we're representing an altitude, you should have right angles, right? Because it's perpendicular to the opposite side. All right, so I have an altitude from here to the opposite side, from this vertex to the opposite side. I now can draw one from here to this opposite side. So now imagine this thing was sitting on this base. Flip it around, I can't flip it around, okay? Draw the height from the vertex perpendicular. You should notice that I'll go through a point. Once again, that's called concurrency. We'll talk about what those are called later, okay? Now, if it is a scalene, acute triangle, they all look kind of like that, and everything's inside the triangle, okay? However, that's not always the case, right? Okay, if I was giving you an area problem and it was a right triangle, there's a right triangle. Where's the height?
On the right angle.
It's this piece, right?
Yeah.
So the altitude of a right triangle is actually a side, right? And how many would I need to draw if I was drawing all of them here?
No.
Well, this would be the other one. And there's one more
But there's nowhere to draw it to make a line.
from the vertex perpendicular, right?
Yeah.
Does that make sense? Okay. So in a right triangle, 2 of the sides represent heights, right?
Yes.
Depending on what base you're sitting it on. Okay? Yes?
How would you do an obtuse
That's next.
one? Sorry.
Okay? So the obtuse triangle is the most complicated, but I like to talk about these as heights because usually people have tried to do the area of an obtuse triangle before. Okay, Daniel? stay with me, you might wanna pay attention to this part, okay? Alright, so here is an obtuse triangle, okay? Now, if I was doing the area of this triangle, I would go 1/2 the base times the height. The base would be here. Where would the height be?
If you took
From the bottom
from
to
the
the
left
top corner.
to the
From here,
top. Yeah.
you would have to be outside the figure to get how tall it is, right? Okay, so your altitudes for obtuse triangles lie outside the figure, okay? Now, by definition, it says from the vertex perpendicular to the opposite side. Well, in this situation, you have to extend the opposite side, okay? So we draw that by going dot, 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 dot to show we're extending the side. And then the altitude is from that point straight down at a right angle. Okay, these might look better if I use another color. Let me show you another color. Okay, so this is just one, okay? How many will we have? 3, so that's 1. Will any of them be inside the figure? 1, okay? So that's the one from this vertex. The one from this vertex would be if this was sitting on the ground, right? So this would go straight like that, right? Okay, does that make sense? Okay, so this one is from this vertex like this at a right angle, right?
Mhm.
All right, how many more have I got? Is it inside or outside the figure? Outside, okay, so to go to the opposite side of this point, I can't go in the figure because every one of these are gonna be an obtuse angle, right?
Yeah.
So I have to extend the opposite side this way, okay? I draw that dot, 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 right? Okay, so we'll do dot, 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 and then we'll go straight up from there like we're sitting on that opposite side, and it would look like that. Now, any questions? Now, imagine that we took this thing and we sat it on this side. We sat it over here on this side, right? Then it would look, I can't draw on the board like that. Then it would look like that, right?
Mhm.
Yes? So if I sat it on this piece, it would look like this and it would go up like that. So this green piece would actually be this piece, right? When I'm turning it, this would be this. This would be this. This would actually be my altitude, right? Does that make sense? Is everybody visualizing that? Okay, now is anybody wondering they're not intersecting all at one point? Like all the others did? They actually do. Okay, here's how that happens. If you extend them on out, I drew them poorly. They land in one point down here somewhere, okay? I drew them poorly, but they do intersect, okay? That has a name as well. We're not gonna get into that yet today. Is everybody doing okay?
Yes.
Okay, so today I want you to know how to draw them. So you're having to do some drawing in this assignment, okay? And get used to the definitions, okay? So, we have done an angle bisector, nothing new. We have done a perpendicular bisector, nothing new. But notice the perpendicular bisector does not go through a vertex every time, right? It's possible it could. It actually did on that figure, okay? But it's blocked, you can't see it, okay? So then you have a few examples over here that are just kind of things you can look at, okay, samples, okay? And then we have some problems on the back that I want to just walk through because this is all dependent on the words, knowing the words, okay? So flip over the back of those notes real quick. Here's a problem, okay? It says find BD. AD is an altitude. To know what to do with this problem, you have to know what that means, right? So you gotta know that means from a vertex perpendicular to the opposite side, right? So what you know in here is, you know this is a right angle. So if you were solving this, you would set that equal to 90 and solve, right?
Yes.
And then you would take your x and plug it in here and get your answer.
So x equals 7 is completely plus 7 is completely useless. Not equals.
Yeah, we're
plus.
not even using it.
Okay.
Okay, it's there as a distractor to see if you know what the word means, okay? All right, everybody okay with that? This one, you're finding angle ABC. BD is the angle bisector, okay? You were given this in the beginning and that in the beginning. Well, if you know it's an angle bisector, you know these are equal. You know this is the same as this. And you know that these two add up to this. We've done problems like this. You get the x, right? And then you plug it back into angle ABC, which is actually here, right? And get your answer,
Yes.
okay? So this is dependent upon you understanding what pieces are congruent, right? Okay, take a look at this one, okay? This one is a median, and it tells you AD is a median, find angle ADC. Okay, so this is not a right angle necessarily, right? These are equal now, right? Because the median goes from a vertex to the midpoint of the opposite side, right? Okay, so you set that equal to that. Solve for x. Take it, plug back into the angle, and get your value. Does that make sense? Okay, so this is dependent on the wording. Perpendicular bisector, find x and y, you set these equal, you get x, this equals 90, right? We did that yesterday, right? Okay, so that kind of gives you, and I don't think you really need this midpoint thing, but it's there. Okay, so that gives you kind of a handle on what you're working on, okay? So you're gonna be working on, the worksheet I gave you, okay? And we omitted number 17. Okay, I will not be here Monday, okay? You guys, do have, a lot of freshmen are gone. Will y'all be back?
We should have over that.
So you guys will be back, okay? You're going to be working on, your multiplying square roots paper that I gave you yesterday that's due Tuesday. I put the answers randomly on the board up here, so when you come back, you can check them, okay? And you should make sure this is ready to go by Tuesday, okay? And then, I may give you something else, but I might not, because most of you are missing class that day anyway.